Hello, this is Peter Carter with a video for the Climate Emergency Institute. The topic is climate change mitigation. It's a video with a difference. In addition, this provides more conclusive evidence that limiting to 1.5 degrees C is impossible, and only immediate global emissions decline can possibly prevent a warming of 2 degrees C by 2050. So this take on mitigation uses atmospheric CO2 equivalent and radiative forcing, the latter from this year's NOAA Greenhouse Gas Index, and using the IPCC fourth assessment for mitigation policy making. It comes with a proposition that the atmospheric CO2 equivalent concentration and radiative forcing are a more reliable way of mitigation assessment than the current carbon budget of more fossil fuels allowed to be burnt. So as an introduction then, all future generations have to be considered in mitigation because global warming lasts over 1,000 years. IPCC assessments up to and including the 2007 fourth assessment used atmospheric CO2 equivalent and the full long-term equilibrium warming long after 2100 as the basis for mitigation. Since the AR4, the IPCC has used the carbon budget from cumulative CO2 emissions and not used the atmospheric CO2 equivalent or radiative forcing. Also, the mitigation targets for 1.5 degrees C and 2 degrees C in the assessments have only been up to 2100. The carbon budget depends on climate sensitivity, for which the IPCC AR6 sixth assessment uses the single unchanging same mean metric of 3 degrees C, excluding the possibility of a climate sensitivity higher than 3 degrees C. Neither the climate sensitivity nor the carbon budget consider extra warming from large sources of amplifying feedback that are likely at 2 degrees C and above, and that increase with the degree and the duration of warming. They do not consider reduced efficiency of carbon sinks at higher atmospheric CO2 concentrations. So, the atmospheric CO2 equivalent and radiative forcing I would propose are a more reliable way of mitigation assessment. I'm starting with the NOAA, which is the first of two sources in the video for atmospheric CO2 equivalent in climate change mitigation. So this is the NOAA Greenhouse Gas Index. The most recent one was published in May of this year, 2022. It's a brilliant, excellent, simple source that I always check through every year. It tells us what we need to know most: atmospheric carbon dioxide concentration, atmospheric CO2 equivalent concentration, which accounts for the other greenhouse gases, and the radiative heat forcing, which is the heat that has been added to the climate system by atmospheric greenhouse gas emissions. So this is on the left is the original image. It shows these three things. The red is what they call the greenhouse gas index, which is the radiative forcing since 1990. And then the pale blue here is atmospheric CO2 concentration, and the black is the atmospheric CO2 equivalent, CO2 plus non-CO2 greenhouse gases. I always remove the red greenhouse gas index because I'm interested in showing clearly the atmospheric CO2 equivalent, which you see on the right there. This is the press release from the NOAA. It was pretty well publicized. June the 7th, 2022, the headline: greenhouse gas pollution trapped 49% more heat in 2021 than in 1990. So these are screen copies instead of formal references from that publication. As I say, the AGGI is the increase in radiative forcing since 1990. There you see the 1.49, and below it the CO2 equivalent in 2021 of 508 ppm, parts per million of air. And the statement in terms of CO2 equivalents, the atmosphere in 2021 contained 508 ppm, of which 415 is carbon dioxide alone. So there's a very big difference between carbon dioxide concentration and the concentration of all the greenhouse gases CO2 equivalent. On the right here, this is very important. This is with respect to future climate change commitment. The NOAA Greenhouse Gas Index measures the commitment society has already made to living in a changing climate. It is based on the highest quality atmospheric observations from sites around the world. Its uncertainty is very low. So there it is. There's the CO2 equivalent of 508 ppm in 2021. And I'm making the point here that this is a reliably accurate, simple and vivid picture of current trends. And it combines these three essentials in the one graph, the two I'm showing here. So the greenhouse gas index is the radiative forcing. I always call it radiative heat forcing, due to the buildup of heat-retaining greenhouse gases in the atmosphere. Since 1990, the radiative forcing has steadily increased, now as fast as ever. You'll see that that is definitely as fast as ever. Since 1990, the forcing has steadily increased. The report also says, as I've shown, CO2 equivalent is 508 parts per million. And you'll see that since 1950 there was a huge increase in the rate of increase of atmospheric CO2 equivalent. These are quite shocking, actually, so I took screenshots of these. In the index, in the paper, the formal paper that goes along with the index, the NOAA has the last year's atmospheric greenhouse gas concentrations, and I'm showing the three main greenhouse gases here, carbon dioxide, methane, and nitrous oxide. And the NOAA in the text here shows that atmospheric greenhouse gases are now increasing actually faster than ever. So you'll see I've got the red blocks around the particular statements. The increase in CO2 is accelerating. The atmospheric burden of methane has increased more rapidly over the past 2 years than at any other point. And nitrous oxide during 2021 and 2000 are among the fastest recorded since measurements began. So, I mean, that's absolutely terrible, because it's now 30 years since the United Nations 1992 Climate Change Convention was signed. So this is the image that NOAA publishes of the radiative heat forcing, and it provides, with those colors on the graph, it provides the proportion of the heating contributed by the greenhouse gases. I got a quote down there at the bottom. The perturbation to direct climate forcing, also termed radiative forcing, that has the largest magnitude and the smallest scientific uncertainty is the forcing related to changes in the atmospheric global abundance of long-lived, well-mixed greenhouse gases, in particular carbon dioxide, methane, nitrous oxide, and then in addition the ones in smaller concentration, mainly the CFCs. So you see the heat from carbon dioxide in the green here. This graph runs from 1991 to 2021. There is the heat from methane. Below that is the heat from nitrous oxide, and in yellow, the heat from CFCs. Now, as I said, the NOAA also provides the radiative forcing, the numerical radiative forcing, which in 2022 had reached 3.222 Wilms per square meter. So the planet is being heated, therefore, faster than ever. There's a record that I took from the Greenhouse Gas Index showing the radiative forcings 2021, 3.222. 2015, it was 2.978. So there is the same image larger, and you can see that CO2 heating is 67% of the total heating of the climate system. Methane has contributed 16% of the heat, and nitrous oxide 6% of the heat. And of course, the vast majority of this heat has gone to ocean heat. So here's a quote from the 2007 fourth assessment of the IPCC, indicating indeed that atmospheric CO2 and radiative forcing are recommended mitigation methods. Quote, a commonly used target in the literature is stabilization of CO2 concentrations in the atmosphere. If more than one greenhouse gas is studied, a useful alternative is to formulate greenhouse gas concentration target in terms of CO2 equivalent concentration or radiative forcing, thereby weighting the concentrations of the different gases by their radiative properties, which is exactly what NOAA has been doing every year. And finally, the AR4 said that the advantage of radiative forcing targets over temperature targets, that's global warming, is that the calculation of radiative forcing does not depend on climate sensitivity. That I didn't know. This is from the IPCC fourth assessment that we're looking at. It's the chart that provides the limits in radiative forcing, atmospheric CO2, and atmospheric CO2 equivalent in order to limit the global surface temperature increase at equilibrium at 2 degrees C. So I've got that written down there. 2 degrees C is 2.5 Wilms per square meter radiative forcing. It's 350 ppm CO2, and it's 445 ppm CO2 equivalent. And that shows on the chart here, if we look for 2 degrees at equilibrium, that corresponds to an atmospheric CO2 concentration of 450 ppm, which corresponds to a CO2 only concentration of 350 ppm and a radiative forcing of 2.5 Wilms per square meter. Now, there have been many publications that for the 2 degrees C equilibrium warming limit, the CO2 equivalent concentration has to be limited to about 445 ppm. So that's 445 ppm CO2 equivalent. I have a few of these in the video, but this one in particular I want to show you now. This is an EU document, an old EU document, and it was the European Union that first in 1996 made the 2 degrees C equilibrium temperature increase limit policy. So this is an EU document, and what it shows is that for a long-term 2 degrees C limit, atmospheric CO2 equivalent needs to be 450 ppm limit. So you can see here for the long-term temperature rise below the 2 degrees C target, studies have shown that to have a 50% probability of limiting the global mean temperature increase to 2 degrees C, the concentration of all greenhouse gases in the atmosphere would need to be stabilized at about 450 ppm CO2 equivalent. So that's really from the horse's mouth, so to speak. The EU, some years ago. Now, in the 90s, it was generally accepted in general knowledge that for the 2 degrees C limit, the atmospheric CO2 equivalent had to be 445 or 450 parts per million. This is another source for 2 degrees C and atmospheric CO2 equivalent. This is from the National Research Council, a major publication in 2011, their climate stabilization targets, emissions concentrations, and impacts. And the National Research Council found the 2 degrees C equilibrium limit was a limit of 430, only 430 parts per million CO2 equivalent. This is for a 66% chance. Some of these, the chances are a little different. I'm not sure whether that makes for the slight difference in the precise concentration. Anyway, this is the lowest one that I've found at 430 parts per million CO2 equivalent. So this is the chart. You see stabilization, CO2 equivalent concentration, equilibrium, global average warming degrees C. There's 2 degrees C, and that corresponds to 430 parts per million of atmospheric CO2 equivalent. Now we go back to the fourth assessment of the IPCC and the NOAA's 2021 atmospheric CO2 equivalent of 508 parts per million. So there's 508 parts per million CO2, and that corresponds to a mean. The black line is the mean. The other two lines are the probability distribution ranges. So that gives us an equilibrium warming of 2.7 degrees C, and the upper range puts it at 4 degrees C. It's entirely consistent with previous findings and conclusions on the old 2 degrees C, which was an equilibrium warming. So I'm starting with the UN Climate Secretariat. This report of November 2009. This says that 450 parts per million CO2 equivalent in the atmosphere corresponds to a 2 to 2.4 degrees C rise in temperature. This one is 2007. It's from the Presidential Action Project. Analyses suggest that stabilizing concentrations below about 400 ppm CO2e would give us about an 80% chance of avoiding crossing the 2 degrees C threshold. This is from a number of world-leading, very well-known climate experts. This was published in 2006. And what this says is the probability of overshooting a 2 degrees C climate target is derived by using different sets of radiating forcing. If the probability shall not exceed above 30%, it seems necessary to peak CO2 equivalent concentrations around 470 parts per million and return to lower levels after peaking of 400 ppm. So that means that 400 ppm CO2 equivalent corresponds to a 2 degrees C equilibrium warming. This is from 2005, one of those well-known climate experts, who states here, only at levels around 400 ppm CO2 equivalents are the risks of overshooting low enough so that the achievement of a 2 degrees C target can be termed likely. So again, 2 degrees C corresponding here to 400 ppm of CO2 equivalents. This is from the OECD, a climate change chapter of 2011, in which it says research shows that if the world could stabilize greenhouse gas concentrations at 400 ppm of CO2e, the chance of keeping the global temperature increase under 2 degrees C would be between 40% and 60%. So that would appear to be a very different conclusion than from the IPCC-6. However, nevertheless, the recommendation is the same, except it's even stronger, that global emissions have to be put into decline immediately and rapidly. We're now going to look at the situation with respect to today's situation and mitigation from the radiative forcing perspective. The radiative heat forcing, that is the total amount of heat that has been added to the climate system from the accumulated greenhouse gas emissions. I'm showing this in confirmation of the NOAA's greenhouse gas index that we've already seen, which in 2021 had atmospheric CO2e equivalent at 508 parts per million and radiative forcing at 3.222 Wilms per square meter. What we're looking at here is the state of the climate in 2020, published by the Australia Bureau of Meteorology and CSIRO. That's their climate science lab. It's actually the Commonwealth Science and Research Organization. Here, this graph here is very similar, of course, to the one we saw from NOAA. This shows a global CO2 equivalent, the one in red, at 508 parts per million, and you can see that that is increasing at an increasing rate since year 2000. And that's the same as NOAA, and there is the atmospheric CO2 at 410. This is the radiative forcing. This is a very good presentation, runs from 1900, and the bottom here, by far the most heating is contributed by carbon dioxide, next methane, next nitrous oxide, and then a significant amount from these synthetic, very powerful, very long-lasting greenhouse gases. And that adds up to, from the Australia Bureau, to a radiative forcing of 3.3 Wilms per square meter. This is that IPCC 2007 fourth assessment, and you see here I've just cut back to the radiative forcing. The radiative forcing is 2.5 watts per square meter for a 2 degrees C equilibrium warming. Now this is the same as a paper that I'm going to turn to next. This paper published April 2020 by V. Ramanathan and others. This is the quote for limiting the warming below 2 degrees C. One important criterion is that radiant energy added by human activities should not exceed 2.5 watts per square meter of the Earth's surface. So there we have the same 2.5 watts, and recall that the 2021 radiative forcing was 3.2 Wilms per square meter. That leads me to the practically universal science fiction delusion, universal apart from James Hansen, of the claim that we can still limit to 1.5 degrees C. This 1.5 C was throughout the most recent United Nations climate change meeting, which was at Bonn in June, and they referred to closing the 1.5 degrees C gap. That's a falsity. Now, and it's also couldn't be more dangerous, because this claim detracts from the dire climate change emergency situation. It's misleading to policymakers, and no doubt is being misused by governments to support their inaction. It contributes to the delay of immediate rapid emissions decline, as is in the IPCC AR6 Working Group 3, stressed by the IPCC chair at the Glasgow COP. It's never mentioned, which is absolutely extraordinary. All of this assumes no extra warming from feedbacks, from amplifying feedbacks, or from carbon sink decline. On the CO2 removal to date, there is no evidence supporting CO2 removal at such scale. The IPCC had a special report on carbon capture and storage back in 2005, and still nothing's really happening. The other thing that I noticed about this is, why would you delay CO2 removal to 2050 to 1.5 degrees C and 2070 for 2 degrees C? If it's understood that the radiative forcing results in a global temperature increase of above 2.5 degrees C, what are you going to do? Well, you're going to put emissions into decline right away, and you're going to start developing, with all resources thrown at it, you're going to start developing a safe and effective CO2 removal right away. From the perspective of today's children worldwide and all future generations, this we can still make 1.5 degrees C is deceptively false.
Welcome to the next lesson of Module 2. This lesson is Energy Basics and Earth's Climate Sensitivity. Before this, you've practiced with the three most commonly used